Part 4 says use your results from part 2 and part 3, last two parts we did, to estimate the overall gain VO4 over VI. What have you assumed in this calculation? Right, well, we've got several numbers so far for the two gains. From part 2, where we were dealing with the differential pair, we had overall gain of minus 1.87. And from part 3, which we just did, we ended up with a gain of 576, I think it was. It's actually probably minus 576. The stage is inverting. So what's the overall gain when we multiply the two together? So VA over VO1 was minus 576, and VO1 over VI was minus 1.87. So VA over VI, so the VO1s have to go away and we end up multiplying these two together. So minus 576 times minus 1.87, and that's going to end up being somewhat more than 1,000. 1.87 times 576, 1,077.12. That's all there is to that. The only other thing you've got to worry about is that it says VO4 in the sheet, which is the output from this bit. I think this is 2K. This is VO4, but we've actually done our working out for this point here, which is VA. The assumption that you're making here is that this common collector stage and this common collector stage, or emitter follower if you prefer, have a unity gain, a voltage gain that is. Actually, their voltage gain is very close to alpha for the transistor, and alpha is ever so slightly less than 1. It's 0.998 probably, something along those lines. Depends on the value of beta. Or if you prefer, you can work it out based on your injection efficiency, if you like semiconductors. So that's the assumption you're making, that VA and VO4 are equal to each other, and that implies that the gain of the output stage, voltage gain of the output stage, is 1, which is very, very nearly true.